Hello and welcome back to our continuation of section 4.3 from our calculus text. We're continuing to look at finding critical points, classifying intervals of increasing and decreasing, and identifying local max and local min values using the first derivative test. And our first function in this segment is the same function that we looked at in the previous section, y equals sine x plus cosine x. I think I used thetas in the previous previous section, but we're still going to be looking at finding local max and local min values for this function on the interval from 0 to 2 pi. It's a little bit different style from what we did in the previous section, but we should see in the end some results turning out to be close to the same, very similar to what we did before. So we first start off by finding the derivative, and I'm not going to belabor this since we did this work in the previous section as well. We find the critical numbers by setting y prime equal to 0. And so in this case, it might be useful to write it as cosine x equals sine x. These two expressions are going to be equal in the first and third quadrants, and we want to remember that it's pi over 4 and 5 pi over 4 that we found as the critical points when we were looking at this previously. So I'm going to do what I did in my earlier examples, find a number line. We're really only looking from 0 to 2 pi. And so my critical point, pi over 4, looks like it might be right around there. And 5 pi over 4 will roughly be here. Our next step is to find test points. I'm going to choose pi over 6 here. I need to pick something between 0 and pi over 4. That's the easiest one for me to work with. And then I'll choose pi here and 3 pi over 2 on that last interval. And so the next thing we do is we look at the sign of the derivative. And so I evaluate at pi over 6. That's going to give me cosine of pi over 6 minus sine of pi over 6. Square root of 3 over 2 minus 1/2. And since square root of 3 is bigger than 1, we know that that difference is positive. At pi, I'm looking at cosine of pi minus sine of pi. Cosine of pi is -1. Sine of pi is 0. That gives me a number which is definitely negative. And then at 3 pi over 2, cosine of 3 pi over 2 minus sine of 3 pi over 2. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is -1, so 0 minus -1 is a positive number. For my behavior of the function, I'm positive derivative, that means the function is increasing. Negative derivative means the function is decreasing. Positive derivative here means the function is increasing. So if I'm going increasing to decreasing, that makes me have a local max here. And if I'm going from decreasing to increasing, that gives me a local min here. So I can summarize this, that f is increasing on 0 to pi over 4 and 5 pi over 4 to 2 pi. F is decreasing in between. F of pi over 4, which we saw last time, is the square root of 2. Square root of 2 plus the square root of 2 gives me the square root of 2 is a local max. And f of 5 pi over 4, which is negative square root of 2 minus square root of 2 equals negative square root of 2 is a local min. So again, you can go back to the video from section 4.2 and you'll discover that we found a lot of the same type of information that we did before, same conclusions. We were calling them absolute maxes and absolute mins previously. And now we're only going to be able to say local max, local min using the first derivative test here. So there are a couple of differences, but again, I invite you to compare and see that we're approaching the same function in a couple of different ways and getting somewhat similar information out of them. My next example is going to use the quotient rule, y equals 16x over x squared plus 4. So again, find critical numbers. So I get 16 times x squared plus 4 minus 16x times 2x over x squared plus 4 squared. And let's expand that out in the numerator. I can combine some like terms. And I'm left with negative 16x squared plus 64 over x squared plus 4 squared. And I can do a little bit of work in that numerator. I can factor out a negative 16, leaving me with negative 16 times x squared minus 4 over x squared plus 4 squared. So notice that the denominator is always positive here. X squared plus 4 will always be 4 or bigger, and if I'm squaring that number, it's certainly also going to be positive. And so my only critical number here is going to come from setting y prime equal to 0. And a fraction is equal to 0 when its numerator is equal to 0. And so all I care about is looking at negative 16 times x squared minus 4 equal to 0. I can get rid of the negative 16 if I divide both sides by negative 16. This is still 0 here. And so I get x squared minus 4 equals 0. X minus 2 times x plus 2 equals 0. My critical points are x equal plus and minus 2. It's a little bit easy to miss that negative 2 if you just try to take the square root of both sides of x squared equals 4. So make sure you get that negative square root here. So that means I need to set up my number line with negative 2 and 2. My test points. Let me choose negative 3, 0, and 3. Generally speaking, it's often good to pick 0 as a critical point or a test point if you can. So let's look at the derivative, the sign of the derivative. So I'm going to use this formulation down here to help me evaluate. So y prime of negative 3 is going to be negative 16. Negative 3 squared is 9, so I get 9 minus 4 over 9 plus 4 squared. So let's think about this. That's negative, that's positive, that's positive. So negative times positive over positive is a negative number. So the sign is negative at negative 3. Y prime of 0 is a little bit easier to evaluate. I get negative 16 times negative 4 over 4 squared. So I get negative times negative over positive. That's a positive quantity. And then lastly, y prime of 3 is going to be negative 16 times 9 minus 4, again, over 9 plus 4 squared. This matches up exactly with what we had on the other side and over at negative 3. And so this is going to be a negative quantity as well. So when it comes to deciding on the behavior of the function, I'm decreasing here, increasing here, decreasing here. So if I'm going down and then up, this is a local min. And if I'm going up and then down, this is a local max. And so I can summarize that f is increasing only between negative 2 and 2. F is decreasing for numbers less than negative 2 and bigger than 2. F of negative 2, which is going to be negative 32 over 4 plus 4, that's negative 4, I believe, is a local min. And f of 2, which is 32 over 4 plus 4, and that's positive 4, is a local max. So let's see what we can do with it. Y equals 3x squared over x squared minus 4. This one's a little bit different in that this time I've got to watch out in my denominator. So notice that y is undefined at x equal plus or minus 2. So we have to watch out for that. So the quotient again, y prime is going to be equal to 6x times x squared minus 4 minus 3x squared times 2x over x squared minus 4 squared. And that looks like I'm going to get 6x cubed minus 24x minus 6x cubed over x squared minus 4 squared. Those cancel out. And so I get minus 24x over x squared minus 4 squared. So in terms of critical points, well, y prime is 0 when the numerator is equal to 0. And so I get x equals 0 as a critical point. And notice that y prime is undefined at x equal plus or minus 2. But since the function was undefined at plus or minus 2, those aren't critical points, but they are points that we need to pay attention to. So they're not strictly critical points because the function isn't defined at that point. So we still need to do some accounting here. So there are 3 places I need to think about this time, plus or minus 2 and 0. So it's going to give us me a somewhat crowded number line. So I'm going to pick my test points. -3, -1, 1, and 3. So then I need to look at the sign of the derivative. So y prime of -3 is going to be, and I'm going to use this expression down here to help me. So it's going to be -24 times -3 is 72 over 9 minus 4 squared. That's a positive quantity. Y prime of -1 is going to be -24 times -1 is 24 over 1 minus 4 squared. That's also a positive quantity. Y prime of 1 is going to be -24 over 1 minus 4 squared. And since the numerator is negative, that's negative, while the denominator is positive. And then y prime of 3 is going to be -72 over 9 minus 4 squared. That's again a negative over a positive, so that's negative. And so I'm increasing, if I'm looking at the behavior of f, I'm increasing here, increasing, decreasing, and decreasing. So the only place where I'm changing, I'm going from going up to going down, is at 0, and so I've got a local max here. So this function is increasing for numbers less than -2 and numbers between -2 and 0. It's decreasing for numbers between 0 and 2 and 2 to infinity. And then f of 0 equals 0 is a local max.